Okay, let's set the scene. It's 1954. You gotta remember, computers back then were these enormous, room-sized behemoths. We think of them as supercalculators. They were built for crunching numbers, for serious math, for cracking codes. The idea that one of these so-called electronic brains could handle something as creative and, well, human as language, that was basically science fiction. But that is exactly what the Georgetown-IBM experiment dared to do.
So that's the massive question staring these researchers in the face. I mean, it's not just about swapping one word for another. Language has rules, grammar, context, all that nuance and style. How on earth do you program that into a machine that only really gets ones and zeros? This experiment, though, it wasn't about solving that whole puzzle at once. It was about taking a very first, very bold step.
And this quote right here is the key to the whole thing. The official goal wasn't to build a perfect translator that you could have a conversation with. No way. The goal was way simpler. To prove it was even possible. To test the feasibility of it all by creating a set of rules that were super simple, but still tackled real problems you find in translation. They were hunting for a proof of concept.
So how do you take this gigantic challenge and make it manageable? Well, they did something kind of brilliant. They realized that when you get right down to it, the act of translating a simple sentence could be boiled down to just two basic kinds of decisions.
And that's it. Selection and arrangement. First, selection. A single Russian word can mean a few different things in English. Which one do you pick? And second, arrangement. Where do you put that word you just chose? English and Russian, they have different sentence structures. So every single problem that machine had to solve was just a version of one of those two choices.
All right, so it's one thing to know what the problems are, but it's a whole other thing to program a machine to actually solve them. And the logic the team came up with was elegant and honestly, almost shockingly simple.
And what's so cool here is that we're looking at an actual page from the machine's dictionary, its glossary. Take a look at the entry for the Russian word K. The machine knows there are two possible English words for it, two or four. Classic selection problem, right? The machine has to make a choice.
Yeah, that's the million-dollar question, isn't it? Without understanding grammar or the actual meaning of the sentence, how could this simple machine possibly know if K should be 2 or 4? Well, the answer was all in its algorithm.
And the process they came up with was just brutally simple. First, the machine finds a word it needs to make a decision about. Then, its entire world just shrinks down to one thing, the word immediately to its left or to its right. That neighboring word had a kind of secret code on it, and that code told the machine exactly what to do.
So these diacritics don't let the fancy name fool you. They weren't some complex linguistic analysis. They were just simple instruction tags. A little code attached to one word might basically tell the word next to it, hey, pick your second English option, or maybe you need to swap places with the word that came before you. It was just a really simple, elegant system of triggers and commands.
So, did it work?
Oh yeah, absolutely. The public demonstration was a huge success, and more importantly, the researchers knew they were onto something. It proved the whole concept was feasible. But, and this is important, its success came from fully understanding its own, very strict limitations.
Just 6. The entire translation program, the one that could translate dozens of Russian sentences, it was built on only 6 simple, programmable rules. That just shows you the power of their approach, right? Define a small, solvable part of the problem, and then solve it perfectly within those tight constraints. And this comparison really hammers home what that core limitation was. A human translator, they read the whole sentence. They get the context, the nuance, the vibe of it all. The 1954 machine, its search span, its entire field of vision was restricted to one single word next to it. That's all it could see.
And this quote from the lead researcher just sums it all up perfectly. The program worked because it was simple. But it was important, it was realistic, because those simple rules were tackling genuine, real-world problems of selection and arrangement, even if it couldn't solve every single one of them.
And that brings us to the real legacy of this experiment. It wasn't about the 40-something sentences it managed to translate. It was about the huge, fundamental question it correctly identified and basically handed off to the next generation of scientists to solve.
See, the real breakthrough here wasn't the technology, it was the thinking. The experiment's greatest gift was that it basically drew a map for everyone who came after them. It correctly formulated the problem of machine translation.
And here it is. This is the big insight, the X on the map. Machine translation isn't just about vocabulary lists or grammar rules. At its absolute core,
It is a decision problem. It's about teaching a machine how to make a series of small, logical choices based on the information it has. This idea? It would shape the entire field for decades to come.
Which brings us right back to that key limitation. The information available to the 1954 machine was tiny. Its search span was just one single word. So it could make a choice based on its immediate neighbor, but it had absolutely no idea what the rest of the sentence was trying to say.
And this is the profound, powerful question the Georgetown-IBM experiment left hanging in the air. They proved a machine could tackle language by making these simple local choices. But in doing so, they revealed the next great mountain that needed to be climbed. How do you give a machine a wider view? How do you expand that search span so it can understand not just words, but phrases and sentences, and maybe, just maybe, meaning? That was the challenge for the next breakthrough.